Let's continue the system design concepts. And today I am going to discuss one of the use case as we whenever we are designing application using the microservice architectures, and we have built a small and independent single seamless business capability in the multiple microservices, and each microservices generally expose the REST API or gRPC API. So we have a somehow each API are exposing a set of API. So from the client perspectives, our UI applications, our mobile applications, our desktop applications, our front-end application, you can say. Front-end applications need to decide which microservice of which instance I have to invoke, and might be this microservice deploy in a different instance. They have a different instance, they have a different machine, they have a different, each have a different IP address, each have a different addresses, host name. So for the client is very hard to know which API I have to call. Those API are belong to the which machines, what are the host name, what are the IP name, what are the port number where this application is running. So these are the challenges we faced whenever we are build lots of microservices, and each microservices are exposed lots of API. So somehow we need some kind of one API management tools or software. So we have a need one software or tool services that's manage our the API. Okay, so that's from the client, maybe front-end application or client mobile desktop are generally aware, hey, this is the my entry point, single entry point for our client. So our client know, hey, this is the my single entry point, I'm just want to call this. So they are not more worry which IP address, which host, maybe dozens of microservices in LinkedIn or Instagram. We have more than 500 microservices deployed. Each microservices have exposed maybe 10 microservice endpoint, 5 endpoint, 20 endpoints. So this is very hard to consume by your front-end applications or the front-end or UI or mobile or client, you can say. So for those, we have to streamline the here front-end application or mobile or UI, you can say client. This is the client, and these are all are the server microservices are service provider. So somehow we make a, because here a couple of service provider list of services provider have, and the client want to access. So if client know everyone, then they can properly communicate. This is very challenge, very tough nowadays due to the scalability issue. Let's see, the same microservice I have started the couple of instances, so still maybe due to the low load we can maybe remove this instances from that. So those scenario client, we have to always to update, hey, this instance are removed or new instance are added, you have to route your call here. So somehow this kind of challenges the client or the front-end application face. So for those scenario, the system designers have a given approach. Hey, from the customer perspective, from the client perspective, we have a single entry point. Hey, here the single entry points are this, the software component are responsible to manage all the API challenges. So this is the new concept come as a API gateway. So in the moderns, the microservice architecture development approach, API gateway play a single entry point for the client, and client doesn't worry the number of microservices you exposed. Client know I have to know this API, this API, this API, this API, and where this API deployed, I have not. Just I call, hey, this is my single entry point, the API gateway. They call the API gateway, and API gateway is responsible to, hey, redirect this call for this microservices or this call for a specific this microservice, right? So this is the very you can say important components, know the API gateway for the modern microservice architecture development. So I'm going to talk brief about the API gateway, so that we should aware while designing our system, we have to tell, hey, this is the API gateway for the clients. So API gateway, as I mentioned, a single entry point for the client. Or the client, here client means customer, client means mobile application, front end application, anyone. To access the collections of microservices are the API, acting as a reverse proxy or routing request to the appropriate services and providing additional feature, security, rate limiting, and analytics. So API gateway is the major functions to route the client request to a specific microservice API. This is the primary objective. And apart from that, API gateway perform some additional operations, facility like security, rate limiting, analytics on your incoming request. So just you consider API gateway a kind of a intermediate or just one software components, and behind the software component list of collections of microservices or APIs deployed on different instances. So client is the only focus on the only single entry point. Clients is just invoke this, hey, this is the my API gateway, this is my applications. So from the client perspectives, they are just assuming they are consuming my services, but they are not directly consuming the specific services. They know this this API have a this API 1, API 2, they have a API 1, API 2. So customer know API details, but they don't know where the actually which instance, which host, which machine the services is running. So for those perspective, client directly communicate to the single entry points, and single entry point, this API gateway is a responsibility to figure out this API is belong to which in microservices, where the particular microservice is installed, what are the IP address, what are the host name, so that they can proper route the request. So look like they work as a reverse proxy kind of things. Means ki, for every request and response on the behalf of microservices, API gateway is interacting. So for the client just send a request to API gateway response. So API gateway play a proxy role for the all the collections of microservices on API. So if talks about API or microservices, similar terminology we can use here, because one microservices can expose a couple of microservices. So here yeah, couple of endpoint, couple of API means sometimes endpoint, API sometimes still microservices. So set of defined rule that enable applications or services or system to communicate with our clients. Simple. API is the one predefined contract between the service provider and the service consumer. Service consumer know how I can consume, or how can tell, hey service, hey microservice, I want to get your these resources. So each microservices generally expose every business capability, every business functionality as a API. So here sometime API considered as a resources, or you can also consider as a URI or URL. So generally you are no for a client consuming any kind of a API, that means they know I want to access this particular resources. So these resources may be I want to get list of product, or view the specific customer, or I want to create the new resources. So lots of standard we maybe talk, maybe get API, post API, put API, delete API. These are the things where microservice exposed, and our client know, hey, these are the API, these are resources I want to consume. So these the microservice, as you know, is the development techniques approach, where say application is the collections of small and independent services. So one services can expose couple of a set of microservices, or you can say one service have a list of resources, or resources you can say, or API you can say, or URI, unified resource identifier. So as a API gateway also discuss works as a reverse proxy, means servers sit between the client and server and the routing request from the client to the server. So from the client perspective, client is thinking I am taking this service from a specific microservice, but actually between the client and actual microservice, the reverse proxy or API gateway available. An API gateway also works considered as a service discovery, because the process of automatically detecting and registering services in the system. That means API gateway have a such kind of facility. They let's example, here we have in the cloud deployed huge collections of microservices. So API gateway have a know, hey, particular new instances come, so this API gateway know, hey, this is the new, so automatically our API gateway find out, detect, hey, this is the one API request come, this API request going to land on this server, are going to land on this server. Okay, so with the help of API gateway configurations, API gateway know to detect the server where the particular microservice, a particular API is in the system, so that they can properly route the request from client to the server. Okay, as a client also know, client is the applications, or maybe front end application, mobile application, any, are the service that can request an API gateway. So client nothing, whatever the requests come to the API gateway, everything here considered as a client. Client not only the front end application, client not only the mobile application, client maybe another application, maybe another cloud application. This application also can interact to the API gateway. From API gateway, any call received, maybe from front end application, mobile application, or maybe in some third party system, or maybe some application, another microservice as well as. So everything considered as a client. And the API gateway, the entry point for the clients and responsible for routing the appropriate request to specific services. This is work as a service registry, or you can say they have a kind of one registry, means a database or repository that store every available services. How our API gateway know, hey, these list of microservices available for me, somehow they have some metadata configuration available in the form of registry or in the form of configuration. From those API gateway find out, hey, this request route to specific microservices. Okay, and services as mentioned are individual microservice or any API that provide the specific business capability. So let's talk about some basics use case scenario. Almost all the modern applications we are developing with the microservice architectures, and every microservice generally expose lots of API. The API gateway is used to manage and route the request to the multiple microservices, and even these API gateway also fit good for the legacy system integration. Let's say we have a once older system want to communicate with a new system, so here API gateway also play important role, just to make the legacy system communicate or integrate with the modern applications. And the main anywhere I want to API management kind of things, the API gateway is one of the API management tools or software component which used to manage and secure API and providing other feature. API management not just routing the call from client to the respective microservice, even the other, so ensure that rate limiting, hey, this microservice have a only capacity in per 10 second or per 20 minute 1000 requests, or such number of requests can handle. So rate limiting for each microservice we can define. We can run the find some analytics tools under the API gateway. Even nowadays this API gateway is very key fit in the serverless architecture. Now the serverless architectures API gateway is also need to manage route the request to the serverless function as well. As the API gateway nowadays maybe event driven architectures or microservice architecture or legacy application and modern serverless architecture as well, as where API gateway play a very critical roles. Whenever I am using API gateway in my application, so by default, these are the some by default our application can get benefit like the simplified for the client code, because the client is now no manage or aware to list of all exposed services on the API. They are very simple. No, hey, this for me, this is the single point of contact I am going to call the API gateway just, and behind the API gateway what number of microservices, what number of independent component API are deployed, that don't worry. So client only no need to know, hey, this is the my API gateway, no individual service detail required. So there is a very little, you can say, comfort for the any client code may be your front-end application, mobile application, or any other microservice, or any other legacy system, or any application you can say. And this our API gateway also kind of improve the level of security, because each microservices, instead of going to apply all the security parameter independently, instead of that those security parameter I can just apply at the API gateway level. So now each and every microservices are not going to do duplicate kind of a work, say authentication, authorization, routing, encryption, decryptions kind of things. Everything we can just move to the one API gateway layer. So our development of microservices individual engineer team is also very less. So our engineer teams can easily deliver new microservices without focusing on common concerns like monitoring, logging, authentication, authorization. Everything we can configure on the API gateway. So lots of additional steps for each and every microservices. As a system engineer, we have to develop, we have to implement those things taken care by our API gateway. And API gateway also ensure that our scalability. If we API gateway help us to handle large amount of requests, making it easier for the application to scale here, because the API gateway look like a very small kind of work. Just receive the request, and as per the configuration they found the specific route and call the here. Now API gateway is free to take another request. API gateway is free to take another request. Due to that help of API gateway, you can say our applications are handle large of the user request or the customer request as well. As this allow us lots of flexibility, because API gateway allow us to easily we can add more services, more instances, and you want to, maybe there is no such more traffic coming, hey, we have to just remove some unnecessary servers or microservices instance that currently not required. So we with the help of API gateway we get up lots of flexibility to adding more and more instances of particular microservices, or removing some instances of the microservices. Even you can add new microservices, you can maybe upgrade any existing microservices. So that's all are the flexibility this API gateway help us. Okay, so if you talk these API gateway, so generally this is the software components, and we as a system designer engineer, we are not going to think how we are going to develop this API gateway as well. Instead of that, already in the market lots of very cheap, very cost effective, very useful gateway available for you. Okay, so the preferences way, don't think how we can build the API gateway. Let's think we can just use the API gateway, and nowadays in the market API gateway available for you. So just we have to aware, hey, I am going to use this. So lots of vendor they are providing API gateway for us. Let's say Amazon provide the API gateway. fully managed API gateway provided by the AWS. Just use, if you are planning to deploy your application on AWS client, AWS cloud, just take the one more managed services API gateway AWS provide. Similarly, all the Google, cloud provider, maybe you talk Google or you talk Microsoft. These are the very big cloud computing resources provider. They provide here the API gateway, and Google also knows the Google Cloud Endpoints or API gateway that's offered by the Google Cloud. Or similarly, Azure API management is also API gateway offered by the Microsoft Azure clouds. Even you can go to the non maybe some open source mode. The NGINX is very useful, you can say, API gateway for the web server or any kind of API gateway management. Even you can go more open source. Kong also have a one of the open source API gateway available. It is on the top of the NGINX. You can also use the KYK, is open source API gateway. It is the build for the Go language. Okay, so just explore. You have a both option. If you decided here we are building the microservice architecture, lots of API exposed by the my different business capability. So surely you need the API management software, API management tool. So API gateway. So you can find maybe cloud provided API gateway, or you can option you have just go and find the open source cloud open source API gateway as well as. And this API gateway, if you look all the modern applications, they are using, you can say, for example, Netflix use the API gateway to manage and route over the user requests from its microservice based architectures. Amazon e-commerce platform also use the Amazon API gateway to manage and route the requests. Uber application also use the API gateway to manage and route the request of the microservice based architecture. So generally nowadays modern applications which are using the microservice based architectures, they are every application they are using the API gateway. Even the different industries where we are developing application using the microservice environment, they are also using the API gateway. Maybe you can Dropbox, Airbnb, and other applications you can find out. Facebook, LinkedIn, everyone they are using the API gateway to managing the API. Okay, so let's look some reference documents that you can say help us whatever we study. That's standard API gateway deployment model structures available. And if you look the AWS websites, and they have given a complete how API gateway works and how they play a role important. Notice here this is the API gateway, Amazon API gateway. And here Amazon API gateway, maybe our dashboard or administrative applications, a client application, they are just communicating to the single point of the API gateway. Maybe our mobile applications or web applications are directly connected to the API gateway. They are not going to directly talk to the particular microservice as a particular services instance. They are talk to the only API gateway. And even a particular our IoT device, they are sensor, they are generating data. So those also directly communicate to the API gateway. And even our private application, local application, other microservices want to get the service of the other microservices, then they can also talk to the API gateway. So API gateway play a very single entry point for our clients, you can say. And here API gateway provide the kind of a fast kind of a response. There are lots of things here like they already use the API gateway caching mechanism. Same requests within a second coming out, they have a cache available and they are quickly response. They can say if we are using the API gateway, our application can improve the performance because our API gateway also offer the cache facility, caching available, and you can once catch them, and your API gateway can route your call, maybe any maybe database call, maybe any EC2 instance, or maybe Lambda function, maybe different kind of any other AWS services you want. Our API gateway can route the call to the specific applications or data center anywhere you want, right? So this is a very good kind of high level architectures for the API gateway. Just you think any kind of user interface, means what kind of interface you expose for the outside of the world, maybe anywhere, maybe via the any connectors user or streaming data, dashboard, application, client, mobile, third party, IoT devices, everyone can communicate to the API gateway. And API, after that, you are under your networking, your subdomain where our API gateway surely route your call to the specific microservices. Okay, so lots of other resources you can just go and read out. Everyone they are using the application designing the modern technology like microservice. They are using API gateway. These are the microservices, notice, and each microservices have a catalog, shopping, discount, ordering, and each have their own database. And notice our client, maybe client ko maybe web application, mobile application, any third party IoT device, dashboard application, front-end application, anyone want to access the catalog service, shopping service, a discount service, ordering service, they are not directly talk to the particular microservice, but instead they are talking to the API gateway. So here all lots of the benefits available here, and these are the main feature of API gateway. You can say API gateway is not just a kind of a routing. You can say even they are providing the some level of your additional feature. Maybe routing is the one key feature of the API gateway, maybe request aggregation, service discovery, maybe load balancing, maybe quality of service assurance, authentication, authorization, throttling, logging, tracing, and other some mid-level custom. So lots of functionality you can this API gateway offer additional for use. So even you can say this is the API gateway also work as a reverse proxy routing gateway as well as. So lots of things here you can say API gateway offer for us. Just you have to read out. So sometime notice the they are API gateway, and sometime you also word the load balancing. So there we last I have not remember last couple of back we have discussed the load balancing. So might be you confused, the load balancing and API gateway look like a similar kind of a functionality, but they have some major you can say key differences business wise. Generally load balancer is responsible to ensure that our system is manage high traffic load and is available for as uptimes, you can say. So here are two terminology, your API gateway and load balancer. Sometimes people are confused, hey, both are the same thing or both are different things when you can API gateway, when I can load balancers. So I think I have already discussed the API gateway is primarily purpose to ensure that clients are interacting. The client know this is the API I want to call. So they call the API, but this API is deployed which microservices. So this is client have lots of confusion. So client say, hey, I have a single entry point for API gateway. The API gateway know, hey, this API, these resources are available under this microservice. This available on this microservice. So here basically API gateway is for the specifically ensuring that the resources what the customer is requesting is available, and find out and divert call to the specific microservices. And here load balancer is the basic responsibility. If applications load is going to increase, so we have a couple of instances. Let's see, one microservice is very highly famous, so it is not a possibility only one instance of this microservice is run. Maybe for example Amazon, and list product or view product. So notice the view product are used by the millions of users. So might be one instance of the microservice of the product. So API, let's give view product. The API is the only one view product, but that this API are consumed by the millions of users. Okay, so the load balancer is play a role here. Say, okay, no problem. Is this API product API have a 10 instances are running? So I am ensuring that every instances are load is distributed. Okay, same all the API gateway, same API, only one API product view, but not possible only one instance can work. So here we are deploy maybe 10 instances of the same microservices, and now our load balancer play a role to distribute load to different instances of the microservices. So here load balancer is responsible to just ensuring that high user traffic request can be handle my applications and be quick responsible. So due to that, we apply the concept of scalability. Scalability means the same instance of the my services are deployed the multiple layer 1 2 10. One microservice may be 10 instances running. So if one microservice is very famous microservices and that can access by the millions users, so our API gateway route to the specific microservices, but they have multiple instances. So those routes are traffic by the load balancer. So load balancer can play a role where they are ensuring that our system is available, highly available, and they are ensure that our systems are even available for the every request. There doesn't matter the number of requests going to high or load. So the major confusion with the developer might be sometime think, hey, let's choose one. Might be many places in a real application we are using the both, because API gateway decided, hey, this is my API product view. Okay, product view API. User know, hey, this is my product view API. Client call our API gateway, and API gateway, hey, fine, might be they have a multiple instances of the same microservices, thousands of microservices. Okay, then here somehow we have to distribute the load among the different machine, different server. So load balancer play a very important role. So sometime our API gateway also play a role of load balancing. So API gateway can say superset, they can manage API related things and even routing, limiting, and load activities. The API gateway sometimes play a role for the load balancing as well as, but always our user traffics are not come with the API. So might be some applications, base application, not go to the API gateway directly. Maybe multiple requests come directly go to the load balancer, and load balancer redirect request to the multiple resources. Maybe multiple API gateway, multiple load balancer. So here load balancer is just distribute any user request, not only API gateway, only API request, even non-API, FTP, any kind of request come, load balancer just distribute load to the different server, so that they are ensure that our system is the available and our system is responsible, and they can handle millions of user requests. Okay, so these are the key challenges. Don't think only I can use the load balancer or I can use the API gateway, or sometime some nature of deployment where we can use the load balancer plus API gateway plus load balancer. Depend upon our use case, instances, and user traffic. Accordingly, we have to ensure it. So couple of articles you can go and read out. I just mentioned, hey, about the API gateway. So as you mentioned, API gateways and load balancer kind of things. The API gateway I discussed, they are doing not just routing, authentication, authorization, rate limiting, load balancing. even they play up a load balancing as well as. Okay, so they play a work of load balancing. Sometimes they play a role load balancing, and even caching, monitoring, logging, transformation, service recoveries, circuit breaker, lots multiple things for fault tolerance. Or particular API is not responding, then what the responsibility. The API gateway, you can say, do a super set. They managing API gateway plus other things. But load balancer is the only responsible. Hey, any user traffic comes, I am going to distribute into the multiple server of the maybe same instances. Here they follow the different routing algorithm we have to discuss. So load balancing is the one, but they had the maybe different routing algorithm they play. So here objective, the load balancer objective is that our system should be available for the high user loads. They maintain the failover. Even we are not something server down, still our system is able to continue. But here objective of client are going to access a particular resources. So API gateway responsible to find out where resources are available and route the request to the specific resources, right? So API gateway can be add more you can say layers, more works like here. So you can directly use the both, but sometimes they are basically mentioned the API gateway basically designed for the API management, protocol translation, routing, versioning, analytic and monitoring. So simply might be you can simple hey, this is the my users using the any kind of apps, and they are going to the call my services, our API gateway. Maybe different API gateway you can use. One for the mobile application API gateway, one for the desktop application mobile API gateway, one for the IoT device, one for the dashboard. So multiple API gateway you can say. And API gateway again doing the routing and place the particular specific microservice, payment gateway, student management, course management, whatever the microservice they are route. Okay. Similarly, load balancer is I mentioned they are distributing, focus on distributing the user, manage the high user traffics, ensure that our system is always available, and according to the different algorithms they play a different role. Maybe just routing the different API. Even notice this load balancer can distribute load to the multiple API gateway. So somewhere you can find the load balancer plus API gateway, both you can use, even the API gateway and load balancer even you can use. So depend upon the nature of your usage of applications. There is only hard and fast rule. First we have to always request go to the load balancer, and then go to the API gateway, then go to the respective server. Sometimes the different deploy model you can try. Let's say I know this is my API, so always route go to the API gateway, go to the find out the particular instance and route, and here might be you can apply the load balancer. If the particular specific API have a lots of instances, that load balancer going to distribute load on the basis of region, on the basis of different priorities. So even these are the kind of load balancer differences between this. You can say here mention our application go to the maybe network level load balancer, or application load balancer, network load balancer, and after that maybe you can go to the API gateway. And API gateway doing lots of additional stuffs like parameter validation, check the particular allow list or non-allow list API, maybe rate limiting, authentication authorization, routing, service discovery, and then a specific microservices they call. Maybe here application load balancer as well as just communicate to the here. Maybe some other non application activities also perform in the load balancer. So lots of resources available, and depend upon our deployment model. We have to also. So sometime we can someone want, hey, load balancer as well as the reverse proxy as well as the API gateway. This is some confusing terminology. So let's be clear concept wise load balancer and reverse proxy and API gateway. So they are well mentioned example for the load balancer and reverse proxy, API gateway, everything. So objective is that maybe directly our client using the internet use the load balancer, and our application server distributed, and our request is going to die. Different types of load balancer are you discuss, and similarly sometime, hey, our user can be different kind of a request to go, and different instance. same instance have a different algorithms here mentioned, right? So we're not going to discuss here. Similarly, again, reverse proxy. Reverse proxy also play a role like our requests are client are not directly communicate to the original server, but they are interacted or communicated to the our only the proxy person, middleware, intermediate server. So this is the kind of receive the request and call the actual microservice, get the response, and so from the client perspective, they have a play a role as a proxy. Proxy means they are not they play a role for the original, but not original, you can say. So here, these are the benefits of it. And sometimes we are going to use the API gateway. API gateway say, this is the client, common API gateway. They are finding the maybe public API, private API, partner API, other API, anywhere call can be routed. So lots of features and benefit available. And even as mentioned, the API gateway are super setup, you can say, reverse proxy, super setup, you can say, load balancing. So they can lots of activity doing API gateway, your parameter validation, allow and deny list, authentication authorizations, and authentication authorization maybe you can use the third party other services as well as, and caching, circuit breaker for fault tolerance mechanism. This particular API is continuous failing, then how our system behave, maybe logging, monitoring, error handling, maybe protocol conversion, service discovery, dynamic routing, rate limiting, lots of things you can configure with the API gateway. So you can say API gateway nowadays become very rich set of functionality and many lots of kind of environment where the you want to integrate. Even you can integrate with it. So API gateway, you can integrate the logging, monitoring as a plugin tool. Say this is the mental. I want to here for logging and monitoring for Prometheus, Grafana, Elasticsearch. You can just plug in them. You confirm, basically just update them and inform them. Hey, for caching mechanism, just update. I'm going to use the A cache, B cache, Redis, and different mem cache. You have to implement them. So lots of you can say kind of advantage and problems with each, but we have to aware them. So notice they are comparing the both our kind of our load balancer have a set of function, our API reverse proxy, and then API gateway. So notice API gateway have a huge rich setup capability. Even they have a kind of a load balancing as well as, and our reverse proxy also play a load balancing. Our load balancer also play a load balancing. So load balancer primary responsibility is distributing the traffics and managing the failover and ensure that every huge volume of requests are taken care of. Okay. And reverse proxy, sometimes just you can just use the reverse proxy where you can just load balancing and caching, some security, SL transmission. You are rewriting something you want, just use the reverse proxy as well as a load balancer. But you want to some more additional activities like routing, authentication, rate limiting, caching, monitoring, logging, tracing, request response, transformation, API composition, service discovery, circuit breaker, rate limited, policy, cache, lots of features you can say this API gateway offers us. So API gateway you can say the very rich functionality. Some nowadays for distributing load, someone maybe use the first request, then load balancer, then API gateway. Sometimes you can find the different architecture. Hey, someone API gateway first, then if the particular specific API have a lots of instances, then we can go to the load balancing. Due to that API gateway, or you can say superset of the load balancer. So particular, this is a particular product view API. This API is routed to, so this is the very famous kind of microservice. So dozens of microservice instances available here. So here somehow we have to apply load balancer to distribute our same API request to the different load balancer. So load balancer responsible to ensure that whatever the instance of my services running, everyone is healthy and particular one services are not going to over or or they are manage huge traffic. So load balancer ensure that every server have a get a equal opportunity and requests are distributed every places so that our applications are responsive, our applications are not you can say available always. So major roles of load balancer ensure that our system would be highly available, and system is the highly available, and is the manage the fault tolerance in the case of some particular and maintain the flexibility. Flexibility, any number of instances we can add and remove, add and remove. So for same microservices, one API gateway had decided, hey, this API is the use, but this API are very famous, and dozens of thousands, hundreds of microservices available. So surely we need a kind of a load balancer to distribute our load to every available server. So you can say we have a sometime we can use only the API gateway, or sometime you can use the combine both API gateway plus load balancer. So as our whatever the designs you are proposing, and that's works, but we should aware these kind of options as a system design engineer we have. Okay, so please just you should aware our different architecture can be. You can directly first go to the your load balancer. After that your request can go to the maybe API gateway, and then API gateway request go to the our couple of specific services are machine. This is the one deployment. Another deployment can be, hey, request go to the first our API gateway, and API gateway decided, hey, going to this microservices, this request microservice, this microservice, or couple of microservices, this microservice, and here you notice they have a huge number of instances of this microservices. Okay, then again may apply the load balancer. Load balancer say, hey, distribute load to the different traffic. So load balancer and API gateway you can decide, and many deployment model you can find somewhere API gateway first, then load balancer, somewhere load balancer, then API gateway. So as per your user traffics and your API popularity, you can go with the API gateway first, or just if you want to know maybe different kind of the load balancer first and then API gateway. So these are both kind of models, many places you can find, and just Google the look the references of other architectures you find. So this is not any fixed and hard rule that, hey, no, all the requests first come to the API gateway and then go to the respective microservices. You can say first my request go to the load balancer, and from the load balancer request go to the API gateway. It's perfectly fine. Someone say, no, first time request go to the API gateway, and API gateway decided, hey, the really load balancing required or not, load balancer required, then load balance to might be load balancer is not required for the particular microservices, only one instance is going on, there is no need, right? So both have a kind of a situation. So here lots of this is the one microservice, they have only one instance, but there is directly our API gateway route to the maybe here the kind of a very less uses of application, there is no load balancer. But some very popular microservices, they have a dozens of hundreds of microservice instances. The API gateway say this is a specific API, the API going to route the specific microservices, but this microservices have a list of hundred of micro instances of same microservices. Here we can apply the load balancer logic, and load balancer distribute logic to the different server, so that our each and every servers are highly available, responsive, and ensure that the reliability and flexibility available in the system. So nature of your maybe before the API gateway you can apply the load balancer here as well. You can hear the load balancer go to the API gateway, and API gateway again maybe route request to the load balancer, and load balancer again route to the maybe API gateway directly route to the specific microservices, right? Directly the service server, there is no multiple instances going on, right? So depend upon your data usage, user traffics, you can decide load balancer, API gateway, load balancer, it is perfectly, or API gateway then load balancer, it is perfectly. So just but as a standard you notice many jo commonly application you find where the first request go to the your load balancer, then API gateway, and then your applications. Okay, and other deployment model may be your API gateway, then load balancer, and then respective microservices. You have to choose your deployment model depend upon your user traffics, volume, and priority kind of things you want. Okay, so these are the basics about the API gateway, and we should aware and we should know API gateway is already available for us, maybe cloud provided or maybe open source. We have to choose right API gateway for our designs. Thank you for watching this.